Welcome to the DigitalituM Podcast, where we delve into the intersection of manufacturing and digital transformation. I'm Marcus Rummel, your host. Manufacturing, a cornerstone of our global economy, faces various challenges, from optimizing production processes to ensuring quality control to maintaining a skilled workforce to stay competitive. In parallel, the digital transformation journey presents its own set of hurdles. Integrating new technologies, managing data, and fostering a culture of continuous improvement are just a few of the obstacles companies encounter in this area. This podcast discusses the problems and, more importantly, the solutions, making a real difference on the shop floor and out in the field. We'll dive into cutting-edge digital tools using technologies like AR, VR, IoT, and AI that are being leveraged to address specific use cases. Whether enhancing your training programs, improving your machine maintenance, or optimizing production workflows, these technologies pave the way for a smarter and more efficient manufacturing operations. In the DigitalituM Podcast, we introduce you to some of the industry-leading voices and peers of mine who are at the forefront of the digital revolution. They'll share their insights, experiences, and the transformative impact of digital tools in their respective field. So please sit back, relax, and join us as we explore the intersection of manufacturing and digital transformation. Welcome to the DigitalituM Podcast. Hello, DigitalituM Podcast listeners. Another episode is out here. And today we welcome Dr. Thomas Schüler, CEO of Helocline, to our podcast.
Hello, Marcus. Thanks for having me.
My pleasure. Let's jump right into that. Can you tell us a little bit more about your professional background and what was your journey in becoming the CEO of Helocline?
Sure, I'm happy to. Yeah, first of all, thanks again for having me here, and it's a pleasure to be talking with you and also with your audience about these interesting topics about virtual reality and about how to use that in manufacturing. Yeah, maybe a few words about me. My background is in computer science, so I have a rather technical view on things. I did my studies over here in Germany. And I also did some research in this domain. So in 2009, I started my PhD, and I was focusing on using virtual reality technology for stroke therapy. So it's a little bit a different topic of what we are doing today. It was also just a few years before this kind of new era of headsets came to the market, where we now see it basically in every electronics store. People can use it in their private areas, which was not possible in 2009. It was still pretty cumbersome technology, and I was using this technology to figure out how people could train movements, relearn movements after they had a stroke. And when I was finished with my PhD, that was the moment where we saw there will be this kind of new technology out there and on the market. And I was always very interested in the question of what is possible with new technology and how could we kind of leverage these things to do things we haven't been able to do before. And so my goal after my PhD was to really go into daily application and figure out ways how to apply the knowledge and spread the use of this technology with productivity tools, with things that people would really use in their everyday life. Mm-hmm. That was basically my origin, and also that way the way it started to become what we have today.
And how did you then get specifically into Helocline and that particular problem solving in shop floor planning for the manufacturing industry? Before you were kind of in a different field, more on the medical side of things. With virtual reality, of course, you can do a lot of different applications. How did you get specifically into this one? What were the contributing factors to that?
Yeah. So what I'm most fascinated about with this technology is how it makes it possible for people to use their natural behavior and then work with digital data and work digitally. And this kind of natural interaction, that's really for me a paradigm shift in how we can use computers basically with this technology. So that's really my technical view on things. So for me, stroke therapy was one area where I could apply this, and I was really fascinated about learning how visual information that you basically get into in a virtual environment, how that could affect motion learning. And especially in stroke, things are very much broken on a neural level. So you have to understand how brain systems work and how you could stimulate brain systems with visual information or virtual information, how that affects motion learning in the real world. So that was fascinating. However, I quickly realized that this area is not an area where you could see this technology really kind of growing and shining in a very, very fast pace, right? Because it's a very complicated and very specific niche. And especially over here in Germany, the medical market is highly regulated. So it's very difficult to get technology there. Also, the trends at that time were very much about getting basically medical data sharing digitally. So it was not so much about therapy and about programs that people wanted to use. So yeah, I just realized that this is not a good area to start with. And then I met in 2014, I met my co-founder, Timo Segemann over here in Germany, who already had a company. He was focusing on doing consulting in the digital area. And I was discussing with him different use cases that we could see for this technology. And through one of his consultants, we really got into this kind of manufacturing environment. And I think the kind of initial click moment was when I learned about a method that's called cardboard engineering, which is something that really fascinated me. It is a method where people in the manufacturing industry would use carton boxes to mock up working environments and to be
Yeah, I
able
saw
to
that before.
quickly. Yeah, it is really fascinating. And I thought, like, wow, it must be a huge problem that people want to solve if they really do this kind of effort to get to a point. Right? And when I saw that, it really made click that, wow, this is something that we can do with virtual reality. And if people invest so much time and so much effort into this is an interesting market to scale. And that was the reason why we ended up what we do today.
That's pretty fascinating. And as I said, I know about the cardboard design and exploration. And the main advantage, to my understanding of this method, is that when you want to measure cycle time on an assembly process, that's more or less the only way to do it, as you have this different cardboard boxes mock-up. And then you have a second person with a stopwatch, and then counting the time for each work step, and write that then manually down in a piece of paper with all the measurement faults which you can make, and writing faults to get not that precise results, but at least it gives you an idea, which you cannot do having a CAD model on your 2D screen and kind of guesstimating how long does it take to assemble something.
Yeah, exactly. I mean, and as you said, it's not very precise, but I mean, the other ways that you could use is just using estimations, which obviously, if you want to produce a product, let's say 10,000 times per year, an estimation is a really weak thing to build your business plan upon. So that's why they are doing that. And yeah, I mean, the other ways and kind of simulation approaches have also been done and researched, but they are extremely complicated to build, right? I mean, imagine a human work process, simulating it to a degree where you could really prove that something could be done the same way in the real world. This is so much work, and that's something that we can do much quicker in VR. We have basically, with the natural interaction capabilities, we have the data that we can use directly to analyze all these things from. It's basically for free. If you start working through processes in VR, you just do it, and you basically have the analysis for free. And that's what's really a huge benefit there.
Yeah, let's dive a little bit deeper in the company HALOCLINE. Can you go a little bit deeper in what's the mission and vision and what particular problem you guys are solving for the industry?
Yeah. So our mission at Helocline is, so we frame it like we empower the practical experts to be creative and to plan their work environments and to plan how to build things safe and efficient. And I think the point practical expert is the most important here, because that what distinguishes us. It's something that you can only do to reach kind of practical experience knowledge. You can't do that if you have to use a mouse and a keyboard and to kind of think mathematically or in processes, but you have to kind of build a digital product that goes close to the kind of real world environment and the real world experience that the people who are planning shop floor environments have. That's really their core knowledge. And if you want to tap into that, you need a digital product that fits into their in their experience domain, right? So that's really what we focus on, and basically the way that we approach it is very close to the cardboard idea. We basically came up with a 3D editor that with which it's extremely easy to quickly sketch and design and test work environments in VR. And so we target it to people without 3D modeling experience. So it means for them it's possible to just draw environments as they would do it in the real world. For example, with carton boxes, they would put a box there, they would add stuff to it, they might cut things out of it. They basically kind of build the environment in a virtual environment in a way that they would also do it in a real environment.
Yeah,
much quicker, obviously.
And to add on that, as I'm a user of HALOCLINE as well, my kids are actually able to use HALOCLINE, and they come here and there to me and say, hey, I want to play in a factory and I want to build a factory today. So it is very intuitive, and you don't need, let's say, 1 week training in how to use it.
Yeah, that's great to hear. And obviously, I mean, in to some degree, it's just a 3D editor. I mean, our printer, we are using it ourselves, for example, to kind of lay out our. Have just recently we have rabbits here, kind of small rabbits that our children are playing with, and I built a stable for them. And it also worked it out in our software. So it's basically just a 3D editor. You can design whatever you want with it, but it's specifically aimed to make it easy to come up with clean and understandable working concepts. I think there's the magic. I mean, if it's 3D editor, you can build it this or that way, but what we really figured out is a way to make it easy for people to come up with concepts for work areas. Which, for example, we have a very good snapping system. Things would align very easily. You would basically come up with an environment that is kind of 90-degree oriented towards each other. So that just like work areas in the shop floor are, right? That's really important, that this is quick and easy. Yeah, so this is basically what we do. And so by what we also enable through this is I mean, if we talk about digitalization in the industry and in the shop floor, I think today we usually see kind of lighthouse projects where this and there's a huge and important, strategically important project where things have been completely digitalized, and they nicely show what is possible with that. But for many of the kind of daily projects that people in the shop floor planning area have to do, this is just too much effort. They don't go through these processes that they have for the lighthouse projects. So what I also believe is that through our technology, we really make possible a full digitalization and a full digital twin of a factory. Because what I believe is most important is that everyone who is part of a real factory can also take part and play a role in the digital factory. And we basically kind of reach out to those guys who have been left out from the project so far because they are not able and not daily using these kind of very complicated digitalized tools, right?
Yeah. Which brings me to the point, the barrier of entry into 3D planning and digital twin is often we don't have the data. We don't have a full 3D model of our entire shop floor. With Helocline, you actually can start with nothing or with just having a little bit. Can you dive a little bit deeper into that, and then also kind of explain how can you import objects and things from the reality and put that all in the virtual reality, and how does this kind of planning process look like?
Sure. So yeah, that was very important for us. That I think when we started our product in 2017, we had a research project, and we quickly had the first early adopters from Mercedes, from Sennheiser over here, and also from Class 3 companies around this area here. And all of them said that typically they don't have data about the current state. And there are so many machines and objects down there in the shop floor that they don't have digital data of, and that they also don't plan to get it in the future of, right? Because you have long time used machinery that you want to keep working, and you don't have data of that. So what they all told us is that their digital plans, digital twins of their factories would usually be completely outdated and have many errors in them, right? So that made us clear that we need to have the possibility to be able to build everything yourself, to change everything in the virtual environment. And I think this really distinguishes us a lot from the typical VR use cases that you see, where you basically use the VR technology to inspect or review data and models that have been generated somewhere else. And someone who is able to generate this model or build a training experience, like a computer science kind of serious game developer, these guys have kind of produced something, and then the actual users of this try it out in a very separate and very late step, right? And there's no loop, right? There's no loop between the design of the virtual world and the testing of the virtual world. And we wanted to bring this together so that you can at all times change whatever you see. You can build new stuff, you can put new objects there, and you can test it out, and you can change again everything. So to have a very close iteration here. And so the way this works is one way I already explained. You can kind of build up objects from the ground up. And maybe this is a good moment in time to share something.
Yes, please.
For your viewers, they can directly see it, and for your audio listeners, we will also share this slide with you. It's just one slide, and I will explain what you can see.
We put the link to that in the show notes.
Yeah. So I think to get a better understanding of our product, it's important to see it one time, because I mean, speaking about virtual reality is difficult. Even just using pictures is difficult, because it's just different if you stand inside it and feel the environment. But this should be sufficient. So what we see on the screen is an image of a virtual factory, kind of screenshotted from a first-person perspective, and you see basically an assembly line for an ATV car that is going to be
kind of like a golf cart.
Yeah, right. Kind of like golf cart. And you see basically three different use cases. So you see a person wearing a VR headset and doing things in the virtual environment. And the one use case I already explained is where you can kind of design new objects directly in the VR based on this kind of cardboard engineering metaphor, where you use a box modeling system and you can quickly draw new objects.
But you also can import objects, CAD objects into the application.
Exactly. We have a vast library of ready-made objects, also in cooperation with the typical suppliers that you know, the vendors that industry companies know. So they will find their catalog of typical standard objects already in our software. And then obviously they also have lots of data about, for example, their product. Typically the product data is completely there. It's modeled in CAD, and we can import basically any kind of CAD object into the environment. And thus you can quickly draw your working area. And what we can also do is we can import point clouds, so kind of scans, laser scans of your real factory environment. So by that, you directly can kind of go down to their shop floor, make a laser scan. You can use iPad technology for that, so very cheap and easy to use technology. And then you can visualize this kind of laser scan in your virtual environment and start drawing your new ideas, your concept around that. So yeah, that's all of these ways are possible. But most important, and you already said it, is that you are able to start working completely on your own. You have no prerequisites, no requirements of someone delivering data to you. You can start directly by yourself.
So more or less you start with an empty hall where you define what is the length, the width, the height, and that creates you a three-dimensional room. And from there, you either import ready-made CAD objects, you import objects from the catalog, or the latest advanced method. If you have, for example, an iPad Pro with the built-in LiDAR scanner, you can generate a point cloud pretty easy, even with a free software, and then import that point cloud of an object into Helocline.
Exactly. Yeah.
And then from there, you can move the objects around and kind of plan and simulate how you want it, test different versions, what's better, version A versus version B. And then from there, I guess we come into the third step, which I'll let you explain.
Yeah. So I already spoke about this close iteration, which is now possible between designing an environment, coming up with a concept, and then testing it. And this is also one of the really nice things about virtual reality. If you have a tool with which you can model a virtual environment, you directly, more or less for free, also have a tool in which you can play around with it, right? And have a physical simulation of this environment. This is really more or less one step. And so this is something that you can also see on this picture. You would see a person who went through an assembly process, who went through assembling an object with the virtual parts and virtual tools that he is equipped with, and by just playing through a assembly process, really going through it step by step, you generate the data that you need to do a full process analysis out of that, right? You kind of grab an object from a carrier, you grab a tool, you put it somewhere, you assemble things, and all these steps will be recorded by our software in the background. And once you've gone through this process, you will get a complete analysis of what you've just done. So you have the benefit of trying things out and get a personal and direct understanding of how it feels to work there. And you also automatically get a analysis out of that. So you can use your experience knowledge to basically individually decide whether this is a good working area, whether you would like to work there, basically. But you also get a complete analysis, which makes it easy for you to adhere to guidelines and all these things that are very important.
For our video viewers, in that assembly setup, we see that there are a lot of these lines going around. Can you explain what they tell us in that evaluation mode?
Yeah. So this is the industry has an interesting word for that, which very much fitting. It's called spaghetti diagrams. So they use these diagrams, for example, to optimize a walking path. And traditionally, they have been drawn by someone standing next to an assembly station and kind of observing a worker there, and then drawing with a pen on a paper the lines that the person would be moving there. And then obviously, if you see, for example, lots of crosses there, you know that this is probably something that you would like to optimize, because it means that the material flow through the station is not optimized. You generally want to have as little walking distances as possible, because that just means it's wasted time, right? You don't want people to walk around, and also, very importantly, people don't want to walk around. It's not just something where you would like to optimize someone else, but it's also, if you walk there personally, you don't want to be walking around to get stuff from racks all over the place. You want to have a smooth process. And this is really something that you can directly see if you see the spaghetti diagram in VR. You see whether there is flow or not. You can directly observe that. And then obviously it's also measured and time measured in the background. You can kind of also get all this data, but most of the times you don't need it. You just have to see it, and you immediately know what you can do better.
And I think that's the big value. Just by looking at the spaghetti diagram, you don't need to be a rocket science engineer to understand it. You just see it. If everything is close together, that looks like an optimal process. But if you have to run here and there a few yards and here and there a few yards to pick up parts, that causes a lot of waste. And in a planning process, sometimes you oversee actually that you have to pick up that one part from a rack which is like 10 yards away. But when you then simulate, you actually see it and you see the result on it.
Exactly.
There's another feature in this, which is the ergonomic analytics. Can you explain that a little bit deeper?
Yeah, sure.
And what that is actually for? What's the whole value proposition of that?
Mm-hmm. So that's also interesting, because there we see that this technology is also very close still to research questions. For example, we have been researching a lot about how to simulate weight, which, if you think about ergonomy, that's one of the first things that you think about, right? Heavy objects lifting and how you can optimize that. So how do we simulate weight? And basically the first important thing is that you need to find a way to assign this information to the data objects. So you would give them, for example, a weight, and then there are kind of standardized methods with which you can check whether an object that is going to be used multiple times throughout an assembly process, whether the way that it is placed in the environment and the way it's moved from A to B through an assembly worker, whether that's something that is still acceptable from an ergonomic standpoint or not. And we can have these analysis completely automated, right? Because we know where the object was put in the first place, and where it ends up in the end, and where it has been all over through the process. And we can take that information and then make this analysis in the background. And the way it would look like is that objects that are not optimally positioned will be kind of yellow marked. So you will know where you have to look at and to optimize for without any other step in between. And also ergonomics is also a lot about, obviously, the movements and the postures of the person who's working there. And since in VR we more or less directly get a human model out of someone using virtual reality technology, we can also analyze the human posture that has been taken there. So, for example, what we can analyze is that typically in an industry working process, you don't want to have to lift your hand above shoulder height, because then blood is flowing back to your heart, right? You don't want that. So that's very simple to calculate in a virtual environment. So we can do that. We can figure out whether you bend down, whether you have to reach for objects far to the ground. So these type of features you have directly accessible from the one playthrough of your process.
Which gives you also the opportunity to test an assembly process with the portfolio of different workers you have. I just point out two extremes. You have short workers and you have tall workers, and they most likely work both at the same assembly station. And for a short worker, things are very difficult to grab if they're too far away. But for the tall worker, there might be too unergonomic when everything is too low.
Yeah. And that's especially important for companies who operate globally, because you have different kind of standardized height distributions all over the world. So that's important. And even it's possible because in our software, you will calibrate yourself to a specific height, and you can calibrate yourself towards a different height. And then you will basically already immediately feel in the VR as if you would have a larger or smaller body. So yeah, that is also an experience which is very interesting to see if you basically operate in a virtual environment and you have, let's say, 10 centimeter longer arms. It's just interesting because you kind of feel very powerful. So yeah, that's an interesting experience to have.
That's actually an interesting feature. So you can, as the test person, you can put yourself into the body of either shorter or taller person and then experience how they feel. But I think it's also possible to, because the software is so intuitive and easy to learn, that a planner, for example, actually brings the, let's say, experienced shop floor worker into the Helocline virtual reality tool to kind of gather their feedback, as a lot of times we have in the industry that issue that a planner, an engineer comes up with an idea and designs something and rolls it out, but the actual people on the shop floor have their practical experience and are often criticizing the planners and, hey, what stuff did you plan there? If I would have done it, I have done it this and this way.
Yeah, sure. And I mean, this is really what the whole cardboard engineering method was about in the first place, right? The thing that we kind of looked at is really a workshop method. It's a situation where people from the different domains would come together and decide about the optimal process. And since we aim exactly at this method, it's really what our customers do a lot, right? So usually they would have, for example, one system positioned somewhere in their office environment where the planners sit and think about new concepts, and they would have a separate system down there on the shop floor, which makes it easy to kind of quickly get people over and talk about concepts and ideas, and that's really something that we would like to kind of move forward, because it is a way of, it's a working style that we software developers are quite used to kind of have really in-depth creative collaboration sessions with different stakeholders in cross-functional areas. And I think that's something that the industry also can make use of a lot.
Is it possible in Helocline to have kind of like a group gathering and bring actually more than one person into the room virtually? Let's say there's a headquarter in Germany, typical example, and a manufacturing plant in the US, so that these two groups can virtually collaborate in virtual reality. Is that possible?
It is possible, and we also have multiple of these use cases and success stories with a couple of our customers. However, I would like to point out that this is not only possible through digital, because the majority of use cases is on-site in the same room with a large screen projection of what the person wearing the headset sees. And then they would just kind of head over the headset, and people would be really interactive on site in one room. And I think it is something that we also really want to focus on in the future to make that a strong point still. However, yeah, as you said, the kind of international collaboration obviously profits from being able to visit the virtual factory together.
And you mentioned already success stories and case studies. Can you explain or share with us a specific success story where Helocline's technology significantly improved the whole shop floor planning and efficiency? And maybe, if you're allowed to, even share some company names.
Yeah, I can do that. I will stop the screen sharing just so that we are visible again as the two of us. So yeah, I would like to share, let's say from two ends, different success stories. I mean, we have been now around for 4 years on the market, and there has been some kind of, so since 2017, we're working on this. There has been some period before even where already early adopters were using our technology. So I think what's important is that to know that the projects that people, the reasons for people to design and change their environment, they are there all the time. It's not something that you want to use in a moment where you build a new factory, you want to use it one time. But it's something that people sometimes think, right? That it's just used for a one-time purpose, one-time project.
Like we say a greenfield project where you
Exactly.
build that new factory, you have that new factory hall, and then you have to fill that hall or that space with equipment.
This is obviously a very good reason to use our tool, but it's not the only reason. But so you should really conceive factories like kind of living systems where things change all the time. It's all the time in under optimization, and you would have products phasing out of manufacturing. You would have new products phasing into manufacturing. And basically, there's always a need to adapt things. That's why I would like to explain maybe two different ends. So one very, very little and small project that we had, for example, an interesting success story together with the company Sana. It's a medical equipment producer over here in Germany, and they have been also collaborating very closely with their supplier of manufacturing material. The company is called ETEM. They build kind of these kind of rack systems and workstation systems.
Yeah, they are supplier of the extrusion material to build all different types of workstations and stuff like that.
Exactly.
Operating in the United States.
Yeah. And they had a project which was just about optimizing one workstation for producing a kind of medical equipment product. And the way that they would have done it previously was they would kind of reserve a 1 week phase for it, where they would kind of build up these workstation with real physical mock-ups, and then they would optimize things, they would kind of reorder things, they would go through different physical prototypes before they would decide on the final one. And it would take them a week with a group of 5-6 people and with lots of kind of interaction with their suppliers and so on. And these guys have been able to do all of that with our technology in 2 hours on a 1-day workshop. So they came together, they went through different iterations, they decided on one of them. And from our software, they directly exported the object structure and sent this as a data format to their supplier and ordered the final version of the equipment directly from our software. So that's a very small project, 2 hours, completely done from scratch, no prerequisites, but you're already done with a complete planning project. And then on the far end side, obviously, as you've already said, the greenfield area, where, for example, with the company Mercedes over here in Bremen, they for their new sports car line, they decided to basically, I mean, the factory building was left intact, but everything that was inside was completely ripped out and built up from ground up. So it was, technically speaking, not a complete greenfield project, but it was very close to it because they were able to change everything and to plan everything new. And it was a 2 years project in which they, with our software, were able to start planning their working stations already before the final car designs had been made. So they already knew that there would be some kind of innovation going on with their new cars where they needed some certain new manufacturing methods for it. And they knew that it would be difficult to do that in a serial process. So they had been able to kind of quickly draw concepts and then discuss with the product engineers, even before the product design was final, how to design these kind of new innovative components in a way that they would be able to assemble it in a serial process. So that was something that they had to do, but they also introduced a new production concept called just-in-sequence material supply, meaning that for every car on the production line, they would have a certain set of product parts that they would need to assemble to it. So they don't have this kind of huge material supply next to the production line, but they would have very dedicated rack systems that would kind of go to, or with autonomous vehicles, they would be delivered to the shop floor area, and then they would be there for certain steps in the assembly process, and then there will come new ones. So there was also a very kind of a huge change in the way that the workers would perform their job there on the worker station. And so they basically built up every single working area in our software, the complete production line, over a project of 2 years, and have many iterations in the different scenarios there. And once they're done with that, they were able to directly from our software build up the real shop floor based on the designs there. And in the end, they saved 2 months. So that they finished their planning 2 months ahead of time, which usually never happens. I mean, usually projects are late, even these kind of large scale projects. But it was something that the manager of this project quickly set this goal very much in the beginning when he saw something like, with that, I want to reach that goal to be quicker than we planned. So to be ahead of time. And they managed to be 2 months ahead of time, which is a lot of money that you can make in 2 months earlier production.
Definitely. Did they use only the planning part for that particular example, or also the test and performance part to actually simulate how the whole workflow works and use that to optimize everything?
In our software, they use all the different parts. I think most important is to understand that the focus of our software is on the individual working area. So you will not have a simulation of all the processes of the complete production line, right? You would go work area by work area. And then obviously for a large production line, you would also have some kind of top-down planning. That was done in systems where our data was exported to. So that was our users could basically prepare the data that was needed to do top-down planning and top-down design afterwards. So basically in the end, they simulated everything, but in our software, they went work area by work area.
Very good. One note about that brownfield project you talked earlier with the medical device company Sanner. There's actually a good YouTube video which kind of explains that process in how did that all go. It's even available in English language, and we put that into the show notes. And if there's any other good use case where you guys have a video, we can put that in the show notes too, to give our listeners a better idea in how this digital tool can be used effectively and bring some value to them.
Sure, that's a very good remark, Marcus. We will put links also to our YouTube channel in general, and I extremely recommend to see that in moving images. I mean, virtual reality is something that you only really understand if you experience it directly, but a video feed of that gives you much better idea than just an image alone.
Yeah. I'd like to share a use case what we had here with DigitalituM, where we helped a local industrial component manufacturer. They moved from a smaller shop floor to a bigger shop floor, and they had to plan that new shop floor. And initially, they want to do it traditionally in 2D CAD by moving the objects around. And we offered the opportunity to plan that in 3D, move all the objects in, and then actually also check it out and create a fly-through video for the German headquarters to give them an idea how the new place actually looks like, other than just the traditional 2D plans, what you get from your realtor and where you put your things in. And that's where we as DigitalituM also can provide that extra value with that planning by using the Helocline software.
Yeah, great.
Let's talk a little bit about the technology itself, virtual reality, or in general, immersive technology, as recently Apple brought, for example, their Vision Pro out. The Meta Quest 3 is kind of a standard in the market. Other companies bring their hardware models out. What is your kind of view of immersive technology? Can you elaborate on that?
Yeah. Yeah, it's mixed feelings. I mean, like probably everyone in the industry, in 2014, when we saw the first Oculus version coming out, I think most of us were assuming a faster pace in adoption of this technology, and I think I was already not so much of the hype group, but I already
Hmm.
had a more kind of um, had a longer time frame in mind. But yeah, it really takes a while, and I think what I learned through this time is. Um, we should be very cautious about what we ask from people in their everyday work life. And we also realized that we would probably have to put more and more of our functions, or to also parts of our software, into desktop tools and tools that you can quickly access while you're working with kind of your mail program and all these things that you do in your office work, right? Because it's a really big step from kind of getting back from your office chair, putting on the headset, diving into this environment, and then starting to work there. I mean, as you said, it's very easy to do with our software, and it's also quick to access, but it's still just kind of the habit-wise. It's so different from your typical work habit. And I think that's something that the technology is still, yeah, kind of, we are as a community, we are still figuring it out how to do that right. And from that point of view, what I'm very fascinated and also convinced of is that beside all the hype cycles that we had over the past years, there was a very steady development in terms of technology and in terms of capacities, what the technology can do. And this really, makes me believe and still see a bright future with this technology. And as you've just said, the Vision Pro and the Quest 3 now really made a big leap. From my point of view, it's a similar big leap as it maybe has been in 2014-15 with the introduction of the first version of the Quest. It's so different, the type these headsets are made, not so much in terms of their technical specifications, but in terms of how they integrate in the typical ecosystems that you are familiar with, right? And that's something that only Apple could really bring to the market, right? I mean, by using the Vision Pro, you directly have access to all your Mac applications and iPad applications that you are used with. So what I see most promising right now is that with these new headsets and with this ecosystem integration, we could see these devices become more multi-purpose, which I think was one of the major drawbacks in the past years, that typically you would have this device just for one thing, and for all the other things you would have other devices. And this is just not a really integrated work life, right? You would like to kind of jump between things. And I think with the Vision Pro and with the ecosystem integration, we could see how this could work out. It still will take a while. I believe we will see another 5 years, steady progress, but no kind of big leaps. And yeah, we just have to figure it out.
And what do you see specifically at the challenges of specifically virtual reality in engineering applications outside of gaming, sports, and entertainment, where the two platforms, Meta Quest and Apple Vision Pro, are pretty much used?
So I think still the major use case that people would see is in e-learning and in education, basically. It is if you use this technology one time, I think what everyone immediately says is that, wow, it feels so real. It feels so immediate. You can understand things so much better because you integrate all this information, not only so for the first time, we are able to also transport implicitly embodied knowledge through digital technology, right? We haven't been able to do that before. It was always rationalized information, explicit information that you could transport by using symbolized information channels. But now we have this kind of natural information channel. And that really means that you can get a personal feeling, a personal impression of doing things. There's a huge application area in education, I think. That's very good. I mean, we already referred to the medical areas of application, which I think this technology has been used for years already. Not so much in the public, I would say, but in terms of planning operation procedures, for example, there's a lot of things that you can do, which obviously you can't do in the real world because you only have that one body. And now we can use your CD scans and you can work with them in a virtual environment. That's also a very strong thing. So yeah, that I think are the most important use cases. But there are obviously many, many more which are smaller. Also, I think in the whole military field, you see a lot of application also to use not so much the complete virtual immersion, but more the kind of extension of things that you see in the real world and adding meta information and extra information into your field of view. And that's highly interesting also.
Yeah, I agree with you. That whole topic of technical training, going back to manufacturing industry, is a hot topic. And we have, for example, our partner IDAR Solution, which particularly focus with an app on that, with the main advantage to bring a 3D model of, for example, a complex production machinery into virtual reality, and then use this immersive view and your hands to train how to either operate that machine or going deeper into any maintenance or retrofit where you have to disassemble a specific assembly group and do maintenance tasks, and you have the ability to actually practice this in kind of real life, but you're independent of your location and you're independent of any timeline. As if you want to practice on the real equipment, for example, a production line, you have to shut that down, which always is a cost issue, and you have to be physically there. While in virtual reality, you can do it somewhere in a training room, and that production line can still run.
Yeah, so I mean, these things are closely coupled also, right? As I've just shown with our software, where you have the productivity area where you can generate data, you can design, you can be creative, but you also have the trying it out area, which is also be used for training purposes, right? If you, with our software, design a manufacturing area, then you can use the same area to as we have already discussed, to get the people from the shop floor in and show them what will be changing. And that's already an educational purpose, basically. So the things are very much coupled. And I believe in this productivity area, the most interesting thing is to think about what people want to design, want to ideate about their room environment, their spatial environment, and now you can do that at room scale, and this I think is ultimately a very creative technology that we have here.
Yeah, definitely. Going back to Helocline, what are some upcoming innovations or new features which you're allowed to talk to, which will roll out soon or in the future? What are some hot topics you guys working on?
Yeah, it's basically two lines. The one is only just recently started. We are still desktop VR bound, and it has been necessary in the past because of performance power, and you need a lot of resources, computing resources.
To explain that to our listeners, the application has to run on a like gaming style PC, so a very powerful machine, and then you're connected with a cable to your virtual reality glass.
Exactly. Thanks for explaining that. So that is our main software today, and we just started a few months ago to basically move our whole product over to standalone headsets, which, as the Vision Pro or Meta Quest 3, they completely run on mobile hardware. So you have the headset and the controllers, sometimes not even controllers, and you're completely equipped. You don't need anything else. Data is obviously linked to some kind of cloud backend. And that means for us that we have to change a lot of things, which we now do. And it's a longer project, but I feel it's extremely exciting because for one, we have this accessibility issue where it's just much more accessible if you have your headset next to you on your desk and you just grab it and put it on your face and you can start working. And then plus, second, we also have this kind of rather new extended and mixed reality features, which with these tools you put on the headset, and the first thing that you will see is your real environment. You just look through the cameras that are built in here, and you see the real environment, and that also again makes it much more accessible because sitting in a office environment, you can still interact with the other guys in the room, right? You're not completely separated from it. So there are so many new capacities that we want to explore, that we want to make use of for our product. So that's I think the most exciting way towards the kind of midterm future where we're working on. And then, as I've already explained a little bit, is what we also figured out is that we need access to the planning and the data that people would generate with our software outside of VR, just with your regular desktop computer, mobile phone, tablet, whatever. Yeah, exactly. So what we are building is just typically 2D web interfaces to access the database and make use of quickly drawing things with mouse and computer. So we believe it doesn't make sense to be dogmatic, just because obviously our main focus is still spatial technology. We try to come up with the best solution and the best UX, and that means also to put parts of our product into other environments, and that's also something that we work on, and that's rather short term. So there are already first things that you can do, and we will add on this and make it easier to work from the desktop computer.
Very good. Thanks for sharing your insights and your outlook with us. As mentioned, we put in the show notes a couple of different links to videos which further show how Helocline works and what value it can bring to us. How can people reach you if they want to get in contact with you or Helocline?
Just shoot me a mail. I believe we also put them in the show notes. You can contact me there. You would probably mostly over here in Europe, you would find me on the typical exhibitions and fairs. And Hannover Messe, for example, was a great experience this year again. One of the largest industry fairs where people would gather. And I'm always happy if I could meet up with people and discuss about this, be it from our target group market, or be it also from the community, and discuss with other VR developers about their experiences. So yeah, I think mail is still the best. You can find me on LinkedIn, obviously, but yeah, this is my main focus is on my mail inbox.
Very good. Thanks for sharing that, and thanks for being a guest at the DigitalituM Podcast.
Great, Marcus. It was a pleasure, and I hope that we were able to bring across all the interesting stuff that we can do with this. Thanks for having me again.
I'm pretty sure. Thank you. Thanks for staying until the end for this DigitalituM Podcast episode. If you enjoyed it, we appreciate a like on your podcast platform. Check out the additional info in the show notes below. Hope you listen again to our next episode. Bye now.